And yeah, so we just wanted to review because this is pretty important for what we're gonna do this time. So does all of this like kind of make sense to everyone? Does everyone like understand this? Because if there's anything unclear, then yeah, I'd be totally happy to explain it a bit slower. Yeah, sorry if that was a bit fast, but it was I thought it was necessary to sort of review what we did last time. So does anyone have any questions or concerns, comments? All right, cool. So now I think we can move on to what I think is very important, like probably one of the most important things in algebra or in math, like which is the representation, which is what these equations actually mean. So when you have an input and an output, when you have an equation like this, that means that for every value of x, say x equals 1, say x equals 2, there's also a corresponding value of y. So we can show this in this kind of table. So if x is 0, then what is y? So you can think about this as sort of x as this equation sort of being of y sort of being an output of the equation and x sort of being input of the equation. And the equation is this sort of like machine that changes this number that you put into it into a number that comes out of it. Hence why it's inputs and outputs. So if x is 0, does anyone know what they think y would equal? Give you a second to think about it. Okay, well, it is kind of complicated, but if we just take y equals 2x plus 1, then we get y equals, so if x equals 0 here, then we get y equals 2 times 0, or I should use that, plus 1. And by the way, just in case that was unclear, 2x, if we just put like a number next to a variable or a variable next to a variable like xy, that actually means 2 times x. But the reason why we don't use the time symbol is kind of obvious right here. Like it gets kind of confusing because the time symbol kind of looks like x, so it gets a little bit confusing. Hence why we just do this, which just looks a lot simpler, a lot cleaner, and there's no confusion. But anyway, back to the original equation. So if we have x equals 0, then y would equal 2 times x plus 1, or 2 times 0 plus 1, which equals, well, what is 2 times 0? What is anything times 0? 0, right? So if we have that, then we get 0 plus 1, which equals 1. That means that y equals 1. So does this kind of process make sense to everybody here? Actually, sorry about that. I'll keep it there for a bit. Okay, so since we have this sort of process, does anyone want to try out what y would be if x equals 1? So Loy thinks it might be 2. So that does make a lot of sense, right? Because we have 2x plus 1. And 2 times 1 equals 2. However, it's not quite exactly the correct answer because we have this sort of a plus 1 right here. And if x equals 1, what we need to do is plug in that 1 into as x, sort of replace x with 1, right? So we would get y equals 2 times 1 plus 1. And what is 2 times 1 plus 1? So Jasper says 3, and so does Lloyd. Yeah, which is correct. Well, like 2 times 1 equals 2, 2 plus 1 equals 3, and what we get is 3. So yeah, this process is a little bit it's a little bit tedious to do it for all of these, but I think we should just do one more just to prove the point. It'll be really cool later, just after we plot these. It'll be it'll be worth it, I promise. So if x equals 2, then what do you think y would equal? Sort of do something similar to what we did last time. So Jasper says 5. Everyone's saying 5. Okay. So yeah, it is in fact 5, right? Like 2 times 2 plus 1 equals 5. Right, so this is this makes a lot of sense. This makes a lot of sense. But what we're gonna do next is something I think is pretty cool. So if we have this kind of chart here, right? Like it's sort of showing if x is a certain number, like 0, 1, 2, 3, then what is y? It shows it in this kind of numerical format in this chart like this. But there's another way to show this information, and that is a graph. So in a graph, you have an x-axis, which would be the bottom axis right here, and a y-axis, which would be this vertical axis. So y is x on the bottom and y on top. Well, it's a little bit arbitrary, but that is how it generally is. But the way we represent information on here is by, for example, on the first one, we represent this sort of row with a point. And that point would be if x is 0, which would be over here, right? Because x is 0, then and y is 1, then it would be here, right? So y you can kind of think of as how far up it is, and x you can think of how left right it is, right? So if x is 0, then it would be here. And I put these sort of markers here just to tell you like kind of what each of these represents. And generally speaking, we're going to put the coordinates, which starts with x and then goes with y, so 0, 1, here. So does anyone kind of want to see what they can do with this one? So kind of in a similar vein, using the x and y coordinates and y values to find the little point on there. So Jasper says 1, 3. So there's actually an annotate kind of a button that should appear on your screen if you go up top. Basically what this does is just allows you to kind of draw on the screen. But if it doesn't work on your computer or like something happens, that's totally fine. Okay.
It helps. It might be on the top of your screen next to where it says you are viewing Inland Empire Math Circle's screen. There's a button called View Options. If you click on it and you go down to the third option, it should say Annotate. Some of you may have it, some computers might not. I'm not totally sure.
Jasper says he still doesn't see it. Okay, so some versions of Zoom might not have this feature, but yeah, so he says 1, 3, which is makes sense, right? And 1, 3 means that the x sort of is that the x what's it called again? Sorry. The x coordinate is going to be 1 and the y coordinate is going to be 3, which just like what we already did means that the point is going to be here. Does the reasoning behind this make sense to everyone? So that means that we have 1, 3, right?
When you're dealing with a graph, generally going right, when you every time you go right, you just keep adding 1 for each row. And when you go up, you add 1 for y. So in this case, if you have 1, 3, you would just move 1 place to the right and 3 times up, because x represents left and right and y represents up and down.
Yeah,
So
you
that's
can
how we
kind of
got
think of it like
to
this.
that coordinate.
So for the third row, which is this one, we kind of just do the same thing, which would be 2 to the right, as Aaron said, which is a great way of thinking about it. 2 to the right, and then 5 up. So if we have 2 to the right, it would be on this column right here, and then 5 up would mean that we would go all the way up here, taking 5 steps up, right? Which would mean that the point is going to be here, this point right here. And then we can also mark that to 5. So something that you may notice about all of these points is, well, actually, what do you notice about all of these points? So what kind of shape do they form? If I sort of draw, like connect them together like this. Whoops, that's not the best connection, like that. What kind of shape do you think, or not even shape, just what kind of, what kind of shape does it form? Like, it doesn't have to be a circle. It could also be like, other kinds of geometric objects. Well, yeah, so it's not very easy to see, like in terms of what because I asked you what shape is. But basically what I was thinking is that this shape, or these 3 points, form a line. They form a line in this graph. And if we extend that line, maybe it would actually help us find, maybe it means that we won't need to calculate what y is by hand. We can just extend the line and look at what the graph says. And right here, what do you think this point right here is? What are its coordinates? So so Jasper says that it is 3, 7, which makes sense, right? So that is the coordinate of that point. So this is relatively straightforward in terms of like what we're doing. But since we know that this point is 3, 7, well, what is y when x equals 3? Then that means that we have 2x plus 1, 2 times 3 plus 1, which equals 7. 2 times 3 equals 6. 6 plus 1 equals 7. And yeah, we figured out that y actually is 7, and we figured that out just by looking at the graph. But what if we don't have the exact point? What if we only have an x coordinate and we don't have, it's not marked on the graph? Well, actually no. Sorry about that. This kind of problem would only be for 0.5. It would only work on a graphing calculator, which we will look at later, since you can zoom in on the kinds of stuff. Sorry about that. So does this kind of like idea make sense to everyone, where you can draw the line on a graph and then the line would help you determine what any other points would be, since every single combination of x and y that meet this sort of equation, that solve this equation, lies on this line. And this is such a nice, concise way of sort of describing all of these points, which go on all the way to infinity, since x can literally be anything. So does this make sense to everybody? Okay, so I think we can also have a little bit more practice with this kind of idea. So let's start out just by drawing 2 points, because if you have 2 points on a line, if we just extend a ruler through those lines, sort of like saying like extending, connecting the lines with connecting the points with a line and then extending that line all the way out, then wouldn't that mean that we have found the entire line? Like before, we had all of this line if we just took these 2 points and we connected them with a line and extended the line all the way out, then yeah, that would be the same line, even if we didn't find the third point. So all we need to do is really find just 2 points. And I think the easiest points to find would be 0 and 1 in this case. So does anyone want to give it a shot, just going through the full sort of process? Give you a second to think about it. So instead of doing the equation before, we're now just doing y equals x plus 4. So if x equals 0, does anyone have any idea as to what y would equal if x equals 0? So Jasper says 4. Does anyone else like have any questions about this? So Loy thinks it's 3. So Loy, why do you think it's 3? And Jasper, why do you think it's 4? So Jasper says because 0 plus 4 equals 4. Yeah, that makes sense. So unfortunately, y would not actually be 3, but yeah, that would work with the last time, with some other kinds of equations. But since we're doing y equals x plus 4, then yeah, it would be 4. So y would equal 4. So graphing on the chart, or like plotting this on the chart, it would be right here. Does this make sense to everybody? So what about for 1? So does anyone have any ideas for what it would be if it was 1? So Jasper thinks it's 5, and that makes sense, right? Because it's because 1 plus 4 equals 5. Yeah, so this is a pretty simple like arithmetic, sort of pretty simple way of representing this. And through this, we would just get 1, 5. And if we extend the line out, then what do we get? A sort of 45-degree line going diagonally, right? So what other points does this line pass through? So if, say, x is 2, then it would be right here. If x is 3, it would be here. If x is 4, it would be there, right? Because every time we're just jumping to the right by one kind of like square thingy. And if x is, let's say x is 2, then what is the y coordinate, or what is the y value of this? 2, yeah. So everyone thinks it's 6, which, makes sense, right? Because 2 plus 4 also equals 6. So basically this graph can help us find every single possible point, or every single possible value of x and y that can fit on here, that can fit this equation. So 2 would be 6, and then for 3 over here, this point, it would be, well, 7, right? Because it's 2 up from 5, which is 5 plus 2 is 7. And if you count that, it would make sense. For 4, which is over here, it would be 8. So does this make sense? Okay. So if let's have a look at what the sort of format of these equations are. So if we go back, let's say, like, you see y equals 2x plus 1, y equals x plus 4, and y equals x plus 4 you can kind of think of as 1 times x plus 4. It sort of fits this sort of format. Y equals mx plus b. So m and b can be sort of any number, and then y and x are sort of the points, are like the y and x of the equation, and m and b could be basically any number. So for this means that basically what this means is that we have m. So m in this case would represent slope. So actually, if you think about it, if we look at what we had before, which, if you remember from this, it was something, it looked kind of like this. The line kind of looked like this, right? For x, y equals x plus 4. Well, in this case, what do you think m is in this case? Y equals x plus 4. So it's going back to this sort of format. What do you think m is? Well, m would be 1, since as previously mentioned, y equals x plus 4 is the same thing as y equals 1 times x plus 4, right? So that means that m in this case would equal 1 for this equation. But for the other one, which was, let's see, 2x plus 1, y equals 2x plus 1, well, then m would equal 2, right? Because we have this number right here, or this, what we call a coefficient, which is sort of like the actual number that gets multiplied by the variable, or that multiplies the variable, is going to be 2. So m equals 2 in this case. So for this first equation, m equals 1, and for this second equation, m equals 2. And m is actually called, this value is kind of called slope. And when you think of a slope, you kind of think of like a sort of something like a diagonal line, or like not really a diagonal line, but you kind of think of something going down, like a diagonal surface. And slope kind of represents how steep this surface is. The higher the slope, the steeper it is. And if we go back to what it looked like before, then we get like for y equals x plus 4, if you remember, it kind of looked like this, right? Like you have this sort of line that's going up like that. It's decently steep. It's like around a 45-degree angle. But if we go back to the other one, which was 2x plus 1, y equals 2x plus 1, if you remember, it looks something like this, right? Oops. Something like this. Sort of looks something like this. It was a lot steeper. And you can see that as the slope increases, the line also gets steeper. So this is basically what slope is. And then for b, which is also known as the y-axis intercept, it basically just means what y equals when x is 0, right? So because on the graph, if say we were here, then when x was 0, it was 4, which also means that when this line intercepts sort of the 0 column like this kind of column here, it's also going to be 0. So this actually helps us draw graphs in the future. So all we need to do is just start out with this point, which is automatically just going to be this value here, which is automatically going to be what we called before, well, b. Okay, no pun intended. Yeah, so this is kind of the equation for this. And it's a little bit like confusing. It's kind of weird. Well, why is this number called m? Why is the y-axis intercept called b? But this is just sort of the overall thing. Like you don't need to memorize the variables, but you sort of need to get a broader idea of what this concept is. So this like stuff all seems a little bit arbitrary, but if we use a graphing calculator, it makes it very, very helpful for solving all kinds of problems. So I'm going to share a different screen. Let's see, which is going to be a graphing calculator. Now this graphing calculator right here, as you can see, is called GeoGebra. So with this, if I say have y equals mx plus b, which is just the equation that we did before, I can create any line. So I can, as m increases, you can see that the line gets steeper. You can also see that the equation, which is this coefficient right here, also gets bigger. It's in fact, of course, it's equal to m. And as it increases, it gets steeper. And as it decreases, it gets less steep. And then with b, if I move it up, it will actually move the line up itself. It kind of looks like the line is moving sort of diagonally, but that's only because the line is kind of infinite in size. But you can also see that where it intercepts, this is sort of called the y-axis, where it intercepts this line right here going up, is also going to be equal to the b, which is the y-axis intercept. And then if I move it up, it's going to change to 3.5, which is b, which is still b.
On
So
the graph,
this is
you'll
kind of
see
like
that the line actually extends to the left more past the 0. And this actually shows that the line works even for negative values. So even if you tried to find a value that was negative for x, you would still be able to find y. But for now, we think of the y-intercept, so b, we think of that as like sort of the starting point. So on the y-axis, and usually when you're solving problems like we will later, you just start with b as 0.
Yeah. So does this sort of like graphing calculator thing kind of make sense? So if you want to play around with the graphing calculator, you can also go on to Desmos, which I will send a link to at the end of the meeting, which is sort of another graphing calculator, but it's a little bit less complicated. It doesn't have all of these other things that don't really relate to equations. And it's like sort of specially designed for these kinds of equations. So let's go back to the presentation. Where are you at? Oh, there you are. Okay. So let's look at a real world example. So if we have a if we have a, well, sorry about this. If we have a, so for example, this problem, Bob has decided to be a paper towel sniffer. He earns $2 for every paper towel he sniffs. If he already has $15 in his piggy bank, how much money will he have after sniffing 6 paper towels? If he wants to buy a laptop that costs $800, how many paper towels does he have to sniff? So the first thing we need to do is to say is to like sort of create an equation based on y and x. So if you remember, x is kind of the input. And in this case, the input is going to be time, right? Like time is going to change as time goes on. Bob is going to make a bit more money, or as the amount of paper towels that he sniffs increases, he's going to make slightly more money. And then y would kind of be the amount of money that he has. So does anyone kind of want to see what like equation would represent this sort of situation? Or I'll give you a moment to think about it because it is a little bit like complicated of a what's it called again? Of a problem.
Remember, an equation for a line just has 4 things that we need to remember. We have y, which is what we're trying to look for. And then we have equals m, which is the slope, x, which is what we put in, so you don't have to find x yet, and plus b. And b is the starting point. So what we have to identify here is m and b, and recall that m is the slope. Another way to think about slope is how much y increases every time x does. So for example, if I put x in, and what is y? But if I add 1 to x, how much does y increase? So in this case, really what you're looking for is how much more money does he make per paper towel that he sniffs? So yeah, it's a little bit complicated, especially with word problems here where you have to deal with everything that's going on. But for this question, we know that he earns $2 for every paper towel he sniffs. Now, what does this mean? So, for example, if he sniffs 1 paper towel, so if X is 1, how much money will he make? What will Y be? Well, Y, if we ignore B, Y would be 2, because we know that, yes. And if he sniffs 1 more paper towel, so if X is 2, what should Y be? Well, think about it. He earns $2 for every paper towel he sniffs. So he'll have $4 now because he sniffed 2 paper towels. Or sorry, if he sniffs 1 paper towel, Y will be $2 because he earns $2 for each. And if he sniffs 2 paper towels, Y will be $4. So the increase in Y every time X increases by 1 is 2 because 4 minus 2 is $2. So that's basically what slope is. It's a little bit confusing, but M in this case would be $2. Every time he sniffs 1 extra paper towels, he gets $2 extra.
Yeah, so every
So
time
next,
Okay.
or no, Eric, you can explain.
So next what we need to look at is, well, what is B, right? So in this case, B would just be the amount that he starts with, because if he has sniffed, say, 0 paper towels, if X equals 0, well then isn't that kind of just what we did before? Like B would just be, B is what Y would be when X equals 0. Well, when X equals 0, that means that he hasn't sniffed a single paper towel. And if he hasn't sniffed a single paper towel, then he's just going to have $15, right? Because he hasn't made any money yet. He just has this $15 that he already had beforehand. So if he just has this $15 beforehand, then we can see that B would actually equal 15, right? Since he would start with $15, and when X is 0, then he would have $15. Does this make sense to everybody? Okay, so now that we have this equation, what do you think we can do to figure out, well, how much money he will have after sniffing 6 paper towels? Oh yeah, and by the way, sniffing paper towels is actually an actual job. It's because paper towel companies don't want smells in their paper towels. Yeah, but anyway, let's get back to the problem. So how much money will he have after sniffing 6 paper towels? So the easiest way to do this is actually to graph. Because the graphing calculator will do all of the information for us. So for example, let's go on our graphing calculator. Let's see, here it is. And if we set, wait, okay, let me share a different way. Switch this, there we go. There we go. Okay, sorry about that. If we set, say, if we remember, the equation was it again? $2 plus 15, m equals 2, and b equals 15, then we get this sort of, we get this equation, this line. And this line right here is sort of similar to the line that we did before. Represents how much money he makes after sniffing 1 paper towel, after sniffing 2 paper towels, after sniffing 3 paper towels, and so on. So all we need to do now is just look at, well, where's 6? 6 goes all the way up here, and it meets with 27. And you can see that this point is going to be 6, 27. And you can see that right here. So since we get the point 627 when it hits the 6 column, that means that he will have $27 after sniffing 6 paper towels. So does this make sense to everybody?
We can check that this works by plugging 6 back into x, into the original equation. So if you look to the left, we have the equation y equals 2x plus, or yes, y equals 2x plus 15, and we plug in 6 for x. So this is another way of solving it, but the problem with this way is you only get 1 point at a time. So we plug in 6, we multiply 2 by 6, which is 12, and then we add 15. So 12 plus 15 is actually 27, which is exactly what the graphing calculator got for us. So we know that it works. However, the benefit of the graphing calculator is now we can look at any point, and instead of needing to plug that point back into x, we can just compare it to what the y value would be. And that's why graphing is so important.
Yeah. So in essence, we are using technology, computers, to help us solve all of these problems without having to do it by hand and without having to do the algebra by hand. And something else that is really cool about this is that we can also use this method to solve other kinds of problems that are much harder than this problem. Oops. So with this second real world example, which we will probably end with, it says Aaron and Eric are running a race. So Eric has a head start of 20 meters. Eric runs at 2 meters per second, while Aaron runs at 3 meters per second. How long will it take for Aaron to catch up to Eric? So with this kind of thing, we can't represent Aaron and Eric with just one equation. What we're going to do is instead find an equation for Aaron and find an equation for Eric. So the easiest way to start is to assume that, well, Aaron starts at x equals 0, or starts at y equals 0, since that's sort of like the beginning when he hasn't ran when he hasn't run like any distance at all yet. And Eric starts at 20 meters. So that means that he starts at y equals 20. So if we have this kind of thing, if we have this situation, then what equation can we do to represent Aaron? since he runs at 3 meters per second. So every second, he runs 3 meters.
So again, what we're trying to do is find what m and b is in the equation y equals mx plus b. So just try for yourself, try to find m and try to find b. We know that m is the slope, and that will have something to do with how fast he runs. So how many meters per second does he run? And b is the starting point. So where does Aaron start?
So essentially what this means is that when x equals 0, which you can also think of x as time, like when the time kind of starts, or like when they're running a race, when the referee kind of blows the whistle, we can just say that's 0, right? Since that's where both Eric and Aaron start, when x equals 0.
Because 0 seconds has passed after he
0
blows his
seconds.
whistle.
And when x equals 0, then when Aaron starts when x equals 0, doesn't it also mean that Aaron starts at y equals 0, right? Because he starts when 0 seconds have passed, he has ran 0 meters. And if this is true, then we can actually plug this in to this formula to figure out what b is and figure out what m is. So if we have y equals 0, then we just say, well, 0 equals mx, m times 0 plus b. And in a way, we can just figure out what b is. 0, this is 0, m times 0 is also 0, so 0 equals 0 plus b. And what this means is that, of course, 0 has to equal 0, right? Because 0 plus 0 equals 0, and there's no other number that you can add 0 to get 0. So that's a lot of saying 0. It doesn't sound like a word anymore, but yeah, that's essentially how you could figure out what b is. So if we know that b equals 0, we can just sort of act like b doesn't exist. All we need to do is figure out what m is. And as Aaron mentioned before, m is sort of the rate of increase. So for every increase in x, which you remember is, for every increase in x, then there is going to be m increase in y. So every second that passes, since remember x represents seconds, so for every second that passes, Aaron will run m meters. And well, according to the problem, how much does Aaron run every second? Well, according to the problem, Aaron runs at 3 meters per second. That means that every second that passes, he will run 3 meters. And if you remember, that means that it would be y equals mx, then that would mean that y equals 3x. And let's think about this for a second. It kind of makes sense, right? Because after 1 second, Aaron will have ran 3 meters. After 2 seconds, he'll have ran 6 meters, and this kind of fits with this, right? Because every second, the amount of meters that he's ran is going to be 3 times the amount of seconds that have passed, right? Since that is the 3 meters per second. Now for Eric, how we can figure out where Eric has ran, what do you think, what do you think is the equation that represents the distance that Eric has ran based on the amount of seconds that have passed? So firstly, we can figure out what m is, right? Because m, as like similar to what we did before, is going to be based on the amount of meters that he runs per second, right? Remember that m is the amount of increase in y for every 1 increase in x. For every second that passes, then there will be 2 meters. He will have ran 2 meters. And that means that we have m equals 2, which means that we have 2x plus b. But then think about it. Eric has a head start of 20 meters. So when x is 0, which is literally when the referee blows the whistle, when x is 0, then how much ahead is Eric compared to Aaron? So how much has he sort of like how far along the track or how far along the race is he in meters? Well, he has a head start of 20 meters. That means that he has, that means that when x equals 0, or when the time equals 0, when 0 seconds have passed since the race began, he will be 20 meters ahead of Aaron. And thus, this means that the equation is going to be 2x plus 20, right? Since b would equal 20. And remember, b is what y equals when x is 0. And now that we have these two equations, y equals 3x and y equals 2x plus 20, which I will put in the chat so that you can remember. Then all we need to do is graph these. And well, you might be wondering, like, how is graphing going to help us find when Aaron is going to catch up to Eric? Well, with graphing, when these two lines intersect, that is when y and x, that the point in which these two lines intersect, is also corresponds to the point in which the y and x values that satisfy these equations are the only two y, x values that satisfy both of these equations. So let's have a look at that with the graphing calculator. Yeah, sorry
What
about
we mean
this.
when we say intersect is we're asking where do the lines cross? Or in other words, where is it so that when x equals the same thing on both sides, y also equals the same thing? So this is actually pretty similar to something we did last time and what we did in our review, right? We had 2 equations and they were in the format of a line, and we're trying to find what x and y equals when both of them are the same. But now, since we have a graphing calculator, it's much, much easier for us because the graphing calculator can draw the lines and it can find where x and y is the same for both lines.
So
we've drawn the 2 lines and we see that they actually meet at point C. And basically what this means is that at point C, which has an x and y coordinate because it is a point, we look at the x coordinate, which is 20, and the y coordinate, which is 60. So what does x represent in this scenario? Well, it represents the amount of seconds that have passed since the race began. And what does 60 represent? It represents the amount of meters that both of them have traveled since the race has started. So since both of these lines have the point 20, 60 on them, that means at 20 seconds, Aaron has traveled 60 meters. And at 20 seconds, Eric has also traveled 60 meters. And recall the question. The question was, how long does it take for Eric or Aaron to catch up to Eric? So when will they be in the same place? And from these results, we can see that they will be in the same place, 60 meters, after 20 seconds have passed. So that essentially answers our question.
Yeah. And so this kind of idea is sort of the basis of what linear equations and what all these equations are helpful for. And graphing calculators really help make our lives just easier. They represent an enormous amount of information in a very small amount of space. And that is why we use graphing calculators. And a computer can just help us create all these lines for us. So in the future, like when a lot of times when solving these kinds of equations, we just plug it straight into the graphing calculator instead of having to solve it all by hand. And there's also a lot of other advantages of graphing calculators that we will discuss next time. So like, there's a lot of other really interesting things that have to do with the shape of the line, that have to do with slope. Like, there's a lot of very interesting things that can come from representing equations in a geometric, in a spatial space. So this lesson was relatively advanced. So like we will upload like a recording, and we will upload the PDF or like the file for this presentation, and also a link to Desmos in like the Discord server and in the WeChat group. Desmos.com or desmos.org. Yeah. So that you can tinker with this and sort of get a feel for this on your own, since a lot of math and a lot of how you get the hang of math is by feel. So we will send a lot of this information later. But other than that, it is 8:13. Yeah, sorry for staying a little bit late since we started a little bit late. Yeah, thank you all for coming. And it was a pleasure talking to you guys.